Hello, my shimmering stars. Today, I, Shora Grover, welcome you all to this amazing platform of PW Gulf. Students, I welcome you all to your Achievers Ultimate Recap session. And what are we going to do today, ma'am? Today, we are going to cover students, your chapter, IUPAC Nomenclature. I hope so, students, you have done a lot of questions, but now it's time to revise it. See students, the importance of IUPAC nomenclature is basically observed in each and every lecture, in each and every chapter. If I'll talk about class 11th or class 12th, you will be observing that IUPAC holds an important role. See, if you don't know how to name a compound, how are you going to do a certain reaction? That means naming is very, very important. Now, in this particular session, I'm not going to start with, the history that how organic compounds were derived and that stuff. No, we are going to revise basically how to do the naming of certain compounds. What rules to be kept in mind, how, which secondary prefix is used, secondary suffix to be used. We are going to understand that. Yes, everyone, I hope so you all are excited for this lecture. Okay, so let's start the session with the beautiful smile. So, ma'am, how are we going to proceed? What are we going to do in this particular session of ours? So, let me tell you students, initially I will be starting with what is the introduction about organic chemistry. Those students, I am not going to go in depth, because I guess this is a revision class and we need to practice more questions in this, yeah? Okay, so after the students, after the introductory part, we will be looking up to the representation of organic compounds. After the students, I will let you know about the hybridization, about degree of carbon and hydrogen, and also we'll be understanding in depth about what is an IUPAC nomenclature and how to do that. That means the last segment basically will, this whole segment will cover your all IUPAC part. Okay, all nomenclature part with regard to simple alkanes, alkynes, or I would say when there is a functional group present such as carboxylic acid, alcohol, aldehyde, ketone, whatsoever it is. We are going to wind up that all in this particular session. Okay, ma'am? Okay. So let's start with the very first part, students. The very first part is, what do you feel is an organic compound? Now, students, organic compound basically is study of hydrocarbons and its derivatives. Hydrocarbons and its derivatives comprises your organic compounds. Okay, so I'm talking about what? I'm talking about organic compounds, and in organic compounds I'm saying that hydrocarbons and its derivatives, students, and its derivatives are referred as hydrocarbons, and basically their study is organic chemistry. Now, coming back over here, let me tell you students, what are hydrocarbons? The one that contains carbon and hydrogen both. The one that contains carbon and hydrogen both. That is basically your hydrocarbons. And what is a derivative, students? Let's take a general example of CH4. If I am going to remove one hydrogen and I'll add something else over here, let's say I'm adding halogen over here. So this creates what? This creates CH3X, which is your alkyl halide. But let me tell you students, alkyl halide basically is what, ma'am? It is your derivative of hydrocarbon. This is a derivative of hydrocarbon. Derivative, that means something you can derive from. Yeah. So if I'm removing one hydrogen and I'm adding some other group over here, this becomes out to be a derivative. Right, everyone? Here you can take X as fluorine, chlorine, bromine, iodine. Okay. Now many of you will say, ma'am, let's take an example. We are adding OH into it by removing one hydrogen. This also creates a derivative. When you're removing one hydrogen and you're adding another group, that is a derivative. But see, it contains what? It contains carbon, hydrogen both, no? So this satisfies the rule that it is a hydrocarbon. Okay, now coming to the next part, students, hydrocarbons basically. Let's talk about now hydrocarbons only. Hydrocarbons basically, students, is subdivided into two categories. What are those two categories? The very first is saturated hydrocarbon. The very first is saturated hydrocarbon, and the second one is unsaturated hydrocarbon. Unsaturated hydrocarbon. What is a saturated hydrocarbon? Let's discuss that. Saturated is the one which contains carbon-carbon single bond. Unsaturated is the one which contains carbon-carbon double bond, or I would say carbon-carbon triple bond. This is what is an unsaturated hydrocarbons. When I am saying a saturated one which contains a carbon-carbon single bond, it is basically your alkanes. What it is, ma'am? It is alkanes. The one which contains carbon-carbon double bond, what it is, ma'am? It is your alkenes. And the one which contains carbon-carbon triple bond is your what, ma'am? It is your alkynes. Yes, everyone? So now you know what is an alkane, in which carbon-carbon single bond is present. What is an alkene, in which carbon-carbon double bond is present. What is alkyne, in which carbon-carbon triple bond is there. See, students, if you are going to classify organic compound, they will be further classified into open and closed, and then into aromatic and the aliphatic one. That is a different scenario. We are not going to do that part. Yes, but I'll let you know at which topic you require what. Yeah. So till now you should know what is an hydrocarbon, how hydrocarbons are classified. Now comes the next part, that is the representation of our organic compound. See, students, if I'll talk about myself, I'm wearing a uniform over here right now. If I'll go on, at my home, I'm going to be in my different clothes. I would say I will be wearing a t-shirt and a jeans. That is a different clothes. If I'm going for a party, I'm wearing different clothes, right? So basically I am a single person wearing different clothes. I can be represented in a various ways. In the same way, organic compound can be represented in so many ways. So let's do the representation of organic compounds. The representation of organic compounds. Now, when we are going to represent organic compounds, we can do so in four ways. Okay, the very first way, students, is basically the molecular formula. The very first way is molecular formula. The second way to represent is condensed structural formula. Condensed structural formula. The third one is expanded structural formula. And the last one, students, is bond line notation. So basically there are four ways to represent a particular compound. The very first is molecular formula, the second is condensed structural formula, the third is expanded structural formula, while fourth is bond line notation. Let's start with them one by one. If I'll talk about the very first one, this is basically your molecular formula. Now, what is a molecular formula? Which is going to tell you the exact number of all the elements present in a certain compound. Okay, so this tells exact number of all the elements in a particular compound. Yes, let's take an example, C4H10. C4H10 is an example in which we have carbon 4, hydrogen 10. So I'm just telling you right now straight away that there are 4 carbon atoms, there are 10 hydrogen atoms. So I'm telling you the exact number. This is what is a molecular formula. Let's talk about the second part, that is condensed structural formula. What is a condensed structural formula? Which is just going to show you the bonds between carbon and carbon atoms. Here you just have to represent the bond between only carbon atoms. When you're representing bond between only carbon and carbon atom, that is what is a condensed structural formula. Okay, let's say if I'm taking this example only C4H10, so I'm going to represent how? 1, 2, 3, 4 carbon. Now see students, always remember a carbon can create only 4 bonds. Okay, so now if I'm considering this carbon, it is creating 1 bond over here. How many bonds is left, ma'am? 3 are left, so that 3 will be done with hydrogen. Let's talk about this carbon. 1 bond over here, 1 bond over here. It is creating 2 bonds. How many are left, ma'am? 2 are left. 2 will be done with hydrogen atom. Let's talk about this carbon. 1 bond over here, 1 bond over here. 2 bonds are being created. How many left? 2 are left, no? So that 2 will be with hydrogen. Let's talk about this. Only 1 bond created, 3 are left, 3 with hydrogen. This is basically the condensed structural formula in which only carbon-carbon bonds are represented. Now let's count carbon. There are 4 carbon. Let's count hydrogen. 3 plus 2, 5. 5 plus 2, 7. 7 plus 3 is 10. So this is C4H10, the same one, right? Okay, ma'am. Now comes the third part. The third part, that is expanded structural formula. When I'm talking about expanded structural formula, here I have to represent all the bonds between the carbon-carbon, between the hydrogen-hydrogen. So just consider the condensed one. Here you have 4 carbons, represent 4 carbons. Now in this carbon, basically 3 more hydrogens are attached at this carbon, so represent 3 like this. There are 2 hydrogens over here, so 1, 1 like this. Here at this carbon again 2 hydrogens, so 1, 1 like this. Here at this carbon it is 3 hydrogen attached like this, so 1, 1, 1, 1 like this. This is what is a condensed structural formula. This is what is condensed structural formula over here. Clear with this part, everyone? Now comes the fourth one, that is bond line notation. Now comes the fourth one, that is bond line notation. See students, when I'm referring to bond line notation, that means I have to only show the bonds. I don't have to write the elements. Here you can write down all bonds to be represented. All bonds to be represented. Coming to bond line notation, here students you just have to represent with the bonds. For example, if we have 4 carbon, no, so this is first carbon, second carbon, third carbon, fourth carbon. These are basically your bonds. Okay, okay. Here dot is just meant for you to understand. In general, I can draw it like this. That means each corner represents 1 carbon and then you can put the valency of hydrogen. So this creates C4H10 over here. Clear with this part, everyone? This is what is a representation of organic compounds. Now let's start with the next part, that is basically your hybridization, students. Let's start with the hybridization. Now see students, when you are calculating hybridization of carbon atom, do remember that pi bond is not included. Pi bond is not included in the hybridization. Pi bond is not included in the hybridization. Now, how you have to calculate? See, you have to see the sum of sigma bond plus lone pair of electrons. If the sum of sigma bond and lone pair of electrons comes out to be 4, hybridization is going to be sp3. If their sum comes out to be 3, hybridization will be sp2. If sum comes out to be 2, hybridization is going to be sp. See, sp3, that means 1s and 3p, that creates 4 sum, that is this. sp2, 3, sp2, right? Now students, how to see what is a sigma bond and a pi bond? See, if there is a single bond, this is a sigma bond. In a double bond, always remember, in a double bond students, the very first bond is a sigma bond, second bond is a pi bond. In the same way, if I'll give you a triple bond case, if I'll give you this case over here, so over here it's very simple. First bond is a sigma bond, second bond is a pi bond, third bond is a pi bond. Clear with this part? Okay, ma'am. Let's, let me give you some question over here for the hybridization so that you can get an idea. For example, if I'll give you CH3, CH, double bond CH, C, triple bond CH. So here you have to, students, tell me the complete hybridization from left to the right direction. We are going to start from left towards the right and you have to tell hybridization of each and every carbon over here. How are you going to tell? See, let's talk about this carbon atom. Creating 3 bonds with hydrogen, 3 sigma bonds, 3 single bonds and 1 bond over here. 4 bonds, hybridization is sp3. Yes, you have to see only the single bond as well as the lone pair of electrons. Coming to the next carbon atom. This one bond over here, one over here, and first bond is sigma bond, second bond is pi bond. Pi bond you don't have to include, so it's 1, 2 and 3. That means it's sp2, ma'am. It is sp2 hybridized, ma'am. Let's talk about the next carbon atom. This carbon creating one bond with hydrogen, one over here and one sigma. Pi is not included. 3. So hybridization is sp2. Let's see the another carbon atom now. Here we have one bond over here, and first is sigma. Second is a pi 1, third is a pi 1. Pi is not included, so 1 and 2. For 2, the sum is hybridization is sp. Let's talk about the third one. See over here, one with hydrogen and one over here, because pi bond is not counted, hence it is 2. So hybridization is sp. By this way, you can calculate the hybridization. By this way, you can calculate the sigma bonds, the pi bonds over here. Clear with this part, everyone? It's very simple. It's very easy, ma'am. Okay. Now, students, let's start with the degree of carbon atoms. Let's proceed with the next part. That is basically the degree of carbon atom. Now see, whensoever you have to see the degree, let me tell you, basically it is of 4 types. The very first is primary carbon. The very first is primary carbon, even referred to as 1 degree carbon. The second one, students, is secondary carbon. Secondary carbon, or even refers to as 2 degree carbon. The third one is tertiary carbon. Third one is tertiary carbon, or even referred to as 3 degree carbon. And the fourth one is quaternary carbon, also represented as 4 degree carbon. Okay, so basically let me explain you these degrees over here. If I talk about primary carbon, it says that when carbon is attached to only one carbon atom, that is a primary carbon. Let's take an example. Example is CH3 bonded with CH3. So here this carbon is attached further with only one carbon, no? So this is basically a 1 degree carbon. This is also attached with one carbon, so this is also 1 degree carbon or a primary carbon. Let's talk about the next one. That is secondary carbon or 2 degree carbon. When carbon atom is attached to 2 carbons, that is basically 2 degree or secondary carbon. Let's take an example. CH3, CH2, CH3. See students, over here, this carbon is attached to one carbon, so it is 1 degree. This carbon is attached to one over here and one over here. 2 carbons, so this is going to be 2 degree. This carbon is attached to one, so it is 1 degree. Clear with this part? Easy? Okay, ma'am. Let's see the next one now. 3 degree or tertiary, when carbon atom is attached with 3 carbon atoms, that creates a 3 degree or a tertiary carbon. Let's see, let's take an example. Now see students, over here, this carbon is attached to one carbon, so it is 1 degree. This carbon is attached to one carbon, so it is 1 degree. This carbon is attached to 1, to 2 and to 3, so it is 3 degree. And this carbon is also attached to 1, so it is 1 degree. Clear with this part? Easy, no? Let's talk about quaternary carbon, or I would say the 4 degree carbon. When carbon atom is attached with 4 carbon atoms, it is quaternary carbon or a 4 degree carbon. Let's take an example. So this is your example over here. Just see students, this carbon atom is linked with one carbon, so it is 1 degree. Yes. This carbon atom is linked with one carbon, so it is 1 degree. This carbon atom is linked with one carbon, so it is 1 degree. This carbon atom is linked with one carbon, so it is 1 degree. This carbon atom is linked with 4 carbons, so it is 4 degree or quaternary carbon. Clear with this part? Very easy. Just everyone write down the degrees of carbon. Now I am going to proceed with the degrees of hydrogen over here. Yes, everyone? Okay. Starting with degree of hydrogen. See now, in the case of degree of hydrogen students, it is also classified into 3 types. It is not classified into 4 types, into 3 types. You will get to know the reason why. Okay. So the very first degree of hydrogen is primary hydrogen. The very first is primary hydrogen. The second one is secondary hydrogen. The third one is tertiary hydrogen. Students, we do not have quaternary hydrogen, remember that. Primary hydrogen is represented as 1 degree hydrogen, secondary hydrogen is represented as 2 degree hydrogen, and tertiary hydrogen is represented as 3 degree hydrogen. Now what are these? Let's understand them. Primary hydrogen is hydrogen attached to primary carbon is primary hydrogen. 1 degree hydrogen or primary hydrogen is the hydrogen that is attached to the primary carbon. Let's talk about the secondary one. Hydrogen attached to 2 degree carbon or secondary carbon is your secondary hydrogen. Simple. Okay. Now what is the tertiary hydrogen? Hydrogen attached to tertiary carbon or 3 degree carbon is tertiary hydrogen. Okay. Now students, I am giving you a case. You have to tell me the total numbers of primary carbon, secondary carbon, tertiary carbon, quaternary carbon, primary hydrogen, secondary hydrogen, tertiary hydrogen, and the answers, right? Okay, let's start. Okay students, first let's see all the carbon atoms and their degrees over here, right? So see students, from this carbon we are starting. This carbon is further attached with 1 carbon, no? So this is primary carbon. This carbon is attached with 1 and 2 carbon, so this is secondary carbon. Yes everyone, this is what is a secondary carbon. Yes everyone. Now, this carbon basically is attached with 1, 2 and 3 carbons over here, so this is tertiary carbon. Let's talk about this attached with 1 and 2 carbon, so this is secondary carbon. If a carbon is attached further with 1 carbon, it is primary carbon. If a carbon is further attached with 2 carbons, it is secondary. If it is further attached with 3 carbons, it is tertiary, and attached with 4 is quaternary. Right? So this is attached with 1, 2 and 3, 4, so this is quaternary or 4 degree. This carbon is attached to 1 carbon, this is 1 degree. This carbon is attached to 1 carbon, this is 1 degree. This carbon is attached to 1 carbon, this is 1 degree. Let's talk about this. This is further attached to 1 carbon, that is 1 degree carbon. Getting my point? Now you have classified the degrees of carbon. Let's talk about the hydrogen. First of all, I want to ask how many 1 degree carbon are present. So it's 1, it's 2. Let's circle the 1 degree one. 1, 2, 3, 4 and 5. Ma'am, there are 5 1 degree carbons. Let's see the next one with white color. The 2 degree carbons. How many 2 degree carbons are there? So it's ma'am 1, it's 2, only 2. Okay. Let's talk about the 3 degree carbon. How many 3 degree carbon, ma'am? Only 1. Okay. Let's talk about the 4 degree carbon. How many 4 degree carbon, ma'am? Only 1. Yes. Now let's talk about the degree of hydrogen atoms. How many 1 degree hydrogen is there? See, hydrogen attached to 1 degree carbon is 1 degree hydrogen, no? So 1 degree carbon is 3 plus 3 6. 6 plus 3 9, 9 plus 3 12, 12 plus 3 is 15. Sorry, yeah. 12 plus 3 is 15. Now let's see 2 degree carbon, 2 degree hydrogen. Hydrogen attached to 2 degree carbon. So it is 2 plus 2, 4. 3 degree hydrogen attached to 3 degree carbon. It is only 1. 4 degree hydrogen is 0. Why? Because 4 degree carbon has already occupied with 4 carbons. Its valency is fulfilled. So there is no hydrogen that will be attached over there. Clear with this part, everyone? Okay, that's really great, students. Now we are going to start with your IUPAC nomenclature. Yes. Let's start with the IUPAC nomenclature part. IUPAC nomenclature. Nomenclature. So students, I guess now you very well know about the general part, that what they can ask you, right? Now we are going to start with the part in which few things are required that I've already told you. See, there is a general formula that you can learn, and that is going to help you out in any complex compounds naming. Okay, so let's start. At the center, students, you need to write word root. See, let me tell you, in a copy, how do we write? From left to right direction, no? But whensoever you are naming a compound, it's the best way to do so. First of all, write at the center the word root, then complete the right hand side portion, and afterwards complete the left hand side portion. By this way, you're not going to go wrong with any question, okay? So coming back over here, we have a word root at the center, and at its right hand side, this is right side, no? This is your right hand side and this is your left hand side, no? So at the right side of the word root, you need to write primary suffix or 1 degree suffix. What you need to write, ma'am? Primary suffix or 1 degree suffix. And its right hand side, you need to write secondary suffix or 2 degree suffix. Secondary suffix or 2 degree suffix. At the left hand side position of word root, you need to write what, ma'am? Primary prefix. What you need to write, ma'am? Primary prefix. And at the left hand side of primary prefix, what you need to write, ma'am? Secondary prefix. So this is a general rule, students, that you should remember while naming any complex compound. Clear with this part? Now let me explain you what are these. What are these? One by one we are going to understand it. Let's start with the word root. Word root represents total number of carbon atoms that are present in a parent chain. Word root represents total number of carbon atoms that are present in a parent chain. For example, there are total 1 carbon present in a compound. So you are going to write meth. There are 2 carbon present in the parent chain. Parent chain is generally the main chain or the longest chain. If there are 2 carbon atoms, you are going to write eth. If there is 3 carbon atoms, students, you will be writing prop. If there are 4 carbon atoms, you are going to write but. If there are 5 carbon atoms, you are going to write pent. If there are 6 carbon atoms, you are going to write hex. If there are 7 carbon atoms, you are going to write hept. If there are 8 carbon atoms, you are going to write oct. If there are 9 carbon atoms, you are going to write non. If there is 10 carbon atoms, you are going to write dec. If there is 11 carbon atoms, you are going to write undec, and for 12 carbon atoms you are going to write do dec. So I guess this is clear to you which word root to be used when there is 1 carbon atom in the parent chain, you will be writing meth. When it is 2, you will be writing eth. When it is 3, you will be writing prop. When it is 4, you will be writing but. When it is 5, pent, hex, then hept, then oct, then non, then dec, then undec, and then do dec. Clear with this part? This is about word root. Now let's talk about, see, one more thing, students. This I am talking of only parent chain. So don't get confused. Sometimes students just see total number of carbon atoms in a complete compound. That goes wrong over here. Okay, they are asking only parent chain. Let's see the next one. Now we have primary suffix. Primary suffix tells the bond between carbon atoms. Between carbon, which kind of bond is there? That represents primary suffix. If there is a single bond between carbon, you are going to use ane, A-N-E. What is the primary suffix used when there is a single bond between carbon? That is ane, A-N-E. When there is a double bond between carbon and carbon, you are going to use E-N-E, ene. What are you going to use, ma'am? Ene, E-N-E. And for, triple bond between carbon atoms, what are you going to use? You are going to use ine, that is Y-N-E. So clear with this part? When there is a single bond between carbon, you will be using ane. When there is a double bond, you will be using ene. When there is a triple bond, you are going to use ine. Let's talk about the secondary suffix part. Now secondary suffix is used for senior most functional group. It is used for senior most functional group. Now, what is the senior most functional group? I will tell you within few minutes. First of all, write this down. Now, coming to the previous part over here, students, let's see this part about primary prefix. See, primary prefix will be applied only for cyclic compound. Used only for cyclic compound. When there is a cyclic compound, you will be using cyclo. What are you going to use, ma'am? We are going to use cyclo when there is a cyclic compound. Otherwise, we are not going to use anything as a primary prefix. When it is an open chain compound, we are not going to use anything. Now, let's talk about the last one over here that we have is secondary prefix. It is used for side chain, For example, if extra CH3 is present, okay, for example, like this, you will be writing methyl. That means any alkyl group is an extra, you are going to write alkyl. See, when there is a CH3 group extra, it will be methyl. When it is 2 carbon extra, ethyl, propyl, butyl, and so on. It can be used for side chain. It can be used for extra group. For example, chlorine, bromine, iodine, fluorine. So for chlorine, you will be writing chloro. For bromine, you will be writing bromo. For iodine, you will be writing iodo. For fluorine, you will be writing fluoro. Clear with this part? Or even it can be used as a junior most functional group. Now, junior most functional group and senior most functional group, what are these? Let me first explain this part. See, basically students, junior most functional group and senior most, when there is only one functional group given to you in your compound, you have to use it in the place of secondary suffix. But when it is given, more than one functional group, then you have to see the seniority order. According to the seniority order, which lies at above position will be given as secondary suffix. The other one will be used as a secondary prefix. This is what is the junior most and the senior most functional group. So now I'm going to write the seniority order over here, students, for each one of you. So before that, students, I would request that first of all, everyone write down this complete rule. This rule is very, very important. First of all, everyone just write down the complete rule. Now I'm going to tell you the seniority order and then we will practice some questions. Okay. Now students, this is basically the seniority order. This is seniority order for functional groups. This is what is, ma'am, seniority order for the functional groups. Now let's come back to this part. These are basically your functional groups. And this is basically the representation part. These are basically your secondary suffix. And this is basically your secondary prefix. Now let's start. See, in a compound, if you're going to see COH, that is C double bond OH, that is basically carboxylic acid. This is what is a carboxylic acid. Okay, and for carboxylic acid, students, if you are using it at secondary suffix, what are you going to use? You will be writing oic acid. You are going to write oic acid in that case only in which basically, the carbon atom of the COH group is being involved. If it is involved in the parent chain, you are going to write oic acid. Otherwise, you can write carboxylic acid if the COH bond is not included in the parent chain. Clear with this part? Okay. Now we are going to talk about secondary prefix. For carboxylic acid, the secondary prefix will be used as carboxy over here, right? Everyone just take a minute, write this down so that I can now move on to the next part of mine. Yes? First of all, write this down, students. Okay, students, so shall I move on to the next part? Yes, everyone. So this was about the very first one, that is carboxylic acid I am talking about. If there is a carboxylic acid written, at the place of secondary suffix, you will be writing oic acid. At the place of secondary prefix, you will be writing carboxy. Let's talk about the next one that we have with us. Now, the next one basically is your sulfonic acid. And for sulfonic acid, you will be observing that SO3H group is attached to a carbon chain or a carbon atom. Now, if it is present, you have to write at the place of secondary suffix the sulfonic acid. But if it is, it is used with carboxylic acid, let's consider a compound contains both sulfonic acid, also carboxylic acid also. Carboxylic will be given the position of secondary suffix. SO3H will be given the position of secondary prefix. It will be used as sulfo. Clear? Okay. Now comes the next part. This is acid anhydride. This is what is acid anhydride. Now this bond represents that here is some RR group like this. So when it is C double bond O and then RR respectively, it creates an acid anhydride, and the secondary suffix for this is going to be oic anhydride. What it is going to be, ma'am? Oic anhydride. There is no secondary prefix for this part. Coming to the next one over here, this is your ester. What it is? Ester, C double bond O. Both ends will contain RR groups. So it is C double bond O and then it is ester. For ester, you are going to write secondary suffix as O8 and secondary prefix will be alkoxycarbonyl. What will be secondary prefix? It will be alkoxycarbonyl. Coming to the next one, basically this is acyl halide, or I would say acid halide. Acyl halide or acid halide, it is one of the same thing, C double bond O X. For this, you are going to write secondary suffix as oil halide and prefix will be halocarbonyl. Halocarbonyl like this. Okay. Coming to the next one, here we have C double bond O NH2. For this, secondary suffix will be used as an amide and secondary prefix will be used over here as carbonyl. Now see students, let me tell you one thing, you have to write in sequence only. This is not one sheet, there is two sheets. Please write them down in a complete sequence. If you are not writing them in a complete sequence, you are going to lack somewhere because these are in order, they are placed in orders. Coming to the next page students, now we have C triple bond N. When C triple bond N students is basically used, that is your secondary suffix will be used as nitrile. And if it is used in the form of prefix, you are going to write cyano. Why? Because C triple bond N represents your cyanide group. Which group, ma'am? Cyanide. After cyanide, we have a group CHO group, which can also be written like this, C double bond OH. It can be written like this. This is basically your aldehyde. And see students, aldehyde starts with Al, so secondary suffix is going to be Al. What is secondary prefix over here? Formyl or oxo. What we will be using? It will be formyl or oxo. Coming to the next C double bond O, it is referred to as ketone. It can also be represented as like this, CO. Okay, and for ketone, basically students, secondary suffix is -one because it ends with -one, and if it is used in the form of prefix, it will be keto-oxo. Let me tell you, for aldehyde, when the aldehyde group is included in the parent chain, it is oxo written as a prefix, but if not included, you will be writing formyl. Coming to the next is alcohol. This is alcohol group. Which one? OH1. Okay. And if alcohol is used, you have to write secondary suffix as ol. See, for aldehyde, we used to write al. For alcohol, we are writing ol. So understand, Al and Ol, don't get confused. Secondary prefix for this will be written as hydroxy. Coming to the next part, if we have SH over here. Yeah, SH over here. So this is thioalcohol basically, and for the secondary suffix will be thiol, and in the form of prefix it will be written as mercepto. Coming to the here, NH2, if NH2 is written, it is a minus secondary suffix, and for prefix is amino. So this is followed by the next page only. So this is the N1, right? So this is the seniority order that you should remember, everybody. Clear? Okay, now students, let's practice some more questions over here. Yes, let's now practice some questions over here. So the very first question, I'm writing first all the questions and then I'm going to do their naming. Okay students, so I am starting with the very first question over here. See, you should remember the same rule. First of all, you have to write word root and then you have to see which is your main chain. So this is my main chain, and in this main chain, this is first, second, third, fourth, fifth respectively. There are 5 carbon atoms. So for 5 carbon atoms, I have to write pent. Right now, after word root we have to write suffix, that is primary suffix. Now what is the bond between carbon and carbon atoms? It is a single bond, so you are going to write ane as over here. This is going to be pentane. Clear guys? Now see students, here we don't have any secondary suffix because we don't have any functional group. Now we have seen what are functional groups. We don't have that, but Is there any primary prefix? No, ma'am. That is used for cyclic compound. It is not a cyclic one. Do we have any secondary prefix? Yes, ma'am. This is CH3. I told you for an extra group CH3 methyl, for a side chain methyl will be written for one carbon. It is present at third carbon, so you're going to write 3-methyl. Always remember, students, there is going to be a dash between the digit and the alphabet. Between digit and alphabet, you have to use a dash. Between both two digits, you have to put a comma. Remember that. Coming to this part now. Here see, it is 1, 2, 3, 4, 5 and 6 carbon atoms. For 6 we will be writing hex. There is a single bond between each and every carbon atom, so it is going to be ane as a primary suffix. Now is there any secondary suffix? No, ma'am, because there is no functional group over here. If there is no functional group over here, then what we can say is that, okay, now coming to prefix part, it is a cyclic ring. Yes, ma'am. So here you will write cyclo. This is primary prefix, which is written at the left hand side of the word root. Then we have two extra groups. This is CH3, CH3. And we are going to write methyl for them, right? And basically, let me just erase it and write it over here again. This is... See, this is an extra group which is written at first and second carbon. So write both the numbers, 1, 2. Now only I told you, if you are writing two numbers together, put a comma. Now comes dash. They are both twice, no, because it is 2CH3. So it comes out to be di, and then it is methyl basically, and then it is cyclohexane. So the name is 1,2-dimethyl cyclohexane. Let's talk about this over here, this compound over here. See, here we have a double bond. So the numbering is going to start from that nearby that carbon atom only. So this is 1, this is 2, this is 3, 4, 5 and 6 respectively. Now for 6 carbon atoms, we are going to write what, ma'am? Hex. Now there is a carbon-carbon double bond at between second and third. When it is given, so choose the smallest number. So the smallest number is 2 over here. So it is going to be hex dash 2 dash ene over here. Remember that, you have to select the smallest number. And this is primary suffix. For double bond, you are going to write ene. So hence I have written over here ene. Now, is there any functional group? No, ma'am. Okay. It is an open chain. Yes, ma'am. It is not a closed, so primary prefix will not be used. But we have an extra group CH3, CH3. We write methyl for them. And we have a Br. For Br, we write bromo. So as per ABCD, you have to go now. A, B, C, D. B comes first, so B will be written first. It is present at fourth carbon. You are going to write 4-bromo. Now you are going to write again number at fourth and fifth position. So 4, 5. There is 2 methyl groups, so it is di-methyl hextuene. See, if there is 3 methyl group, you will be writing tri. If 4, it is tetra. Clear with this naming? Coming to this part over here, let's start. Here is the triple bond. So this will be first carbon, second carbon, third, fourth, fifth, sixth. Now you will go here or you will come down? We will come down. Why? Because there is a bigger chain. So more the number of carbon atoms, more is the longer is the chain, is more stable one. So coming to this one. For 8 carbon, we have to see the longest chain rule over here, right? If we have 8 carbon atoms, we will be writing oct. There is a triple bond between first and second carbon atom. So the lowest number will be written. It will be oct 1-ine over here. Now see students, there is no functional group over here, but yes, we have 2 extra groups. This is methyl group and this is bromine group, so it is bromo. Now again, as per ABCD, bromine is going to come first. So this is going to be what, ma'am? This is going to be 3-bromo, then again dash, then it is going to be 6-methyl. Then it is oct 1-ene. Is it clear to each and every one of you? It was simple, I guess. Yes. Okay. Now let's do some more questions based upon the functional groups part, so that it is more clear to each one of you. So this is basically CH3, CH, CH2, CH2, CH3. Question 2 is COH, CH2, CH, COH, CH2, COH. Okay students, let's do with this part now. See over here in the very first question. So we are going to start the numbering from the functional group. So here CH is the functional group. This is first carbon, second carbon, third carbon and fourth carbon. Now for 4 carbon atoms, we are going to write but as a word root. There is a single bond between carbon and carbon atoms. So you are going to write ane over here. Now what is a functional group? We have a CHO functional group, an aldehyde functional group. Now what is the secondary suffix used? We are going to write al, A-L over here. See, butane ends with E and aldehyde al starts with A. So 2 vowels cannot be together, so it is going to be E. We are going to deduct over here. It is present at first carbon, so it is butane 1-al. Now we have an extra group over here, which is CH3, which is methyl group, which is used as a secondary prefix. So it is present at second carbon, so it is basically 2-methyl butane 1-ul. Yes, everyone? Okay, that's great. Now let's come to this compound. See, it's first carbon, second carbon, third carbon, fourth and fifth. Now these are included in the parent chain. For 5 carbon atoms, what are we going to write? We'll be writing pent. Now, between carbon, how many bonds, which kind of a bond is there? Single bond, so it is N. Now, we have a carboxylic acid, COH present, which is present at the first carbon atom as well as at the fifth carbon atom. So, this E won't come first of all because we write oic acid over here. So this is pentane 1,5. Now there is 2 carboxylic acid in the main chain. So it's dioic acid. When do we write oic acid over here? When it is included in the parent chain. COH is included. Now this COH is not included. We were not able to include it out. This is present on third one. So it will be used as a prefix. And we used to write carboxy. So this is going to be 3 carboxy pentane 1,5-dioic acid. Clear? Students, this question is again a priority one question. If you will see, it is going to be like this. Right, this is first carbon, second carbon, third, fourth, fifth and sixth. Now for 6 carbon atoms we are going to write hex. There is a single bond between carbon, it's ane. Priority will be given to the senior most, that is carboxylic acid, that is COH. So it is going to be hexane 1-oic acid. Simple. Now we have some extra groups over here. For OH we will be writing hydroxy. Yes, there is a C double bond O. For C double bond O we are going to write oxo because it is a ketone. Now as per ABCD, H is going to come first, so it is going to be 3 hydroxy, then it is going to be 5 oxohexane 1-oic acid. Clear with this part, students? So such kinds of questions are generally asked. Now students, I am going to give you some of the homework questions over here which you have to try by your own and write your answer in the comment section. So I have explained you the simple naming, the IUPAC naming part over here. Yes, everyone? Okay, ma'am. So now come some homework questions. Try to do them by your own. This is first question as a homework. This is second question as a homework. Okay, students. So please write down these homework questions so that you can analyze yourself, everyone, that whether you are able to solve them or not. Yes, everyone. So this is basically the homework question of yours which you can try and you will get an idea that whether you are doing the IUPAC part easily or not. Now students, we shall be meeting in the next class. Till then, keep smiling, keep learning. Thank you so much. I hope so this lecture was quite clear to each and every one of you and you are able to understand each and every topic in detail. So I have started from the initial part and we have done the IUPAC part. Now it's turn for you to practice it out and see and self-analyze yourself that whether you are able to understand it or not. So you can write your answers in the comment section. I will be looking up to the comments. I will be responding you over there. Yes, students. So thank you so much. Have a good day. Keep smiling. Keep learning.